Okay, so let's go ahead and get started. We're going to do page 416, example number 5. In example number 5, we come to an interesting question where we have cotangent 1 plus cotangent squared 1 plus cosecant. Book has x used, I'm just going to use x. And then I have this is equal to cotangent x secant minus tangent x secant minus tangent x. Okay. So these two do not look the same at all. They're totally different. The only thing that's common is you have 2 of these and you have maybe 1 of these here, right? So, I don't know, but the rest is really all over the place. So, what was our strategy if I don't know what to do?
Everything
to sine and cosine. So let's go ahead and start from the left-hand side and see where we get. Okay, so I'm going to go from here. On the top, I'm going to have sine squared x cosine squared x. Oops, no, the other way around.
Like, what?
Say something, please. Cosine squared x, sine squared x. Over here, I get 1 plus 1 over sine x. Okay, well, at least they're all in sines and cosines, okay? And I can actually multiply top and bottom by sine squared x, right? Just get rid of the fractions. Okay, so now this guy and this guy cancels out. I get cosine squared x. I get sine squared x plus 1. So I'm making more. So I'm making some more progress here.
Can you just get sine plus 1?
Where? Here? Mm-hmm. No, this is sine x plus 1.
Why?
If it was a minus 1, then I could say this is cosine.
But is it sine
sine squared x times 1 over sine x?
Let's go over here.
Yeah.
And that's where I got the 1. But I still have to do this guy over here, right?
Oh.
Wait, what?
Oh, I see.
I'm multiplying this through. All I'm doing is distributing it, right? I'm distributing it. So this times this is this. This times this is this.
Extra sine?
How was this? Oh, never mind. Sine x. Thank you. Okay. And we're here, right? Okay. So what do I need to get? Where do I need to get? I need this. This needs to be, because the end result that I'm looking for is cotangent x. And what's the other one? Oh my gosh. Secant minus tangent. Secant minus tangent. This is what I need to get. So I need to still get from here to here. Okay.
Sine over cosine for the tangent.
Okay, so now here's where we're going to do something that's a little different. Okay, so instead of trying to plow through and get to here, I'm going to try to go from here over here and see if I can have a meeting point. So if I get to a point where they're the same, I'm okay, right? So let's take this guy, cotangent x, secant x minus tan x. I'm going to go ahead and put everything in sines and cosines. Cosine x, sine x, 1 over cosine x plus and minus sine x over cosine x.
1 over cosine.
Okay, so let's distribute this out. If I multiply this guy to this guy, what do I get?
Sine.
1 over sine x.
I was close.
Because these guys cancel out, right? And I have 1 over sine x. Multiply times this guy, what do I get?
1.
Negative 1.
Okay.
Okay, all right. So if I combine this, what do I get? I get sine x 1 minus sine x.
Wait, how
Okay.
do you do that?
So we're getting closer here. Now I have to make this guy look like this or this guy look like this, right? Either way it works. As long as you find a middle point. Yes?
I might be like not understanding. How does 1 over sine x minus 1 equal 1 minus sine x over sine x? I guess. Okay.
I'm just combining the denominators, all I'm doing.
Somewhat.
Combining the denominators, right? Okay. So let's see if we can make this look like this or this look like that.
Yeah.
So how would I do this?
You multiply by sine squared.
Well, I'm going to pull a sine x out here, okay? It's going to be sine x plus 1. Do we see that?
Yeah.
We good with that?
Not really.
Right? But again, I have this on the bottom, on the top now. So if I multiply top and bottom by okay, so I'm going to rewrite this to make it look easier for you guys. What is this times this?
Why is the book doing like 2 steps?
What is this times this?
1
1 minus sine squared x, which is
1 cosine squared.
cosine squared x. So this, and this all cancel out.
And then you're left with it.
And I'm left with 1 minus sine x over ding, 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 winner.
That's the big No one won
Here's the
Be smarter than the letters, not even the numbers, the letters.
Okay,
That's just
are we good?
Yeah, wait, how did you get an answer but the book did it weird?
Then what
we
did the
don't
book
learn
do?
the
It's like 30 different.
Well, it's the same thing.
Okay.
They did this, I had 1, right? This was 1. And they just changed this to cosecant x minus 1. Cosecant x minus 1. It's the same thing. Right? And where, okay. So in other words, well, I have the same point. So actually, as far as proof goes, I am not done. Right? Because I have to rewrite this now to go from here through this way
Wait, really?
to come back up to here, right? So the true proof is going to be this is the same as this guy.
We have to show this.
And then this goes to here, right? Is the same as cosine x, sine x, 1 minus cosine x, minus sine x over cosine x. And this is the same as that. And this is the cotangent x, secant x minus tangent x. And that's your final proof. Because now I've walked my way from here all the way through to the right-hand side. Is what?
Can we just have a button on the calculator that makes it
Just gives us like a thumbs up.
Just give it a thumbs
keep
up.
going? It gives us motivational message.
Okay, let's move on to the last one. So on page 417, in the middle, it gives you some useful identities that you will use in AP Calc. Okay?
That's funny. If we take it.
This is correct, if you take AP Calc.
Yeah, actually, I'm rethinking that one too.
Okay, all right. So, where are we at? We are there. So let's do example number 6.
Logarithms.
This is actually pretty simple compared to what we just did.
Oh.
Okay, so example number 6, I have sine squared x
I feel
cosine.
like you said that for all of them, and it hasn't. been.
Oh, really?
Yeah.
I've been
You're
lying?
like, it's
Are you
okay,
accusing
easier
me of
for you.
lying?
No, just implying.
And I want to get to where? I want to prove that this is going to be equal to sine squared x 2 sine to the 4th x plus
Well,
6th, right? Cosine x, is it cosine x? Okay. So what do you notice about this guy? This is long.
I don't know.
But if they all share 2 sine x's, right?
Yes.
Now, so I can pull this out if I wanted to, right? So if I pulled it out, it's going to look like this, right? So if I pull it out, it becomes a lot easier. 1 minus 2 sine squared x plus sine to the 4th x cosine x. What does this look like? Isn't this a squared plus 2ab plus b squared?
Huh?
Sine squared x. This is the same as 1 minus sine squared x squared.
Yeah, Mr. Ron.
Where did you get this?
A squared, b squared,
C squared.
and this is 2ab.
2AB.
What was that? Oh, you just.
That's like common algebra.
Right? A squared plus b plus a squared plus b squared is equal to a squared plus 2ab plus b squared, right?
Oh.
That's what I'm doing here, right?
A squared plus 2.
What is this?
1.
No, that.
It's
The
A
thing
plus
above
B.
it.
It's cosine squared x.
Yeah.
Isn't this cosine squared x?
Yeah.
So this is going to be equal to the sine squared x. This is cosine squared x, you told me. Sine squared x. But I'm squaring this. Cosine x. Well, I squared the squared. How many do I get? To the 4th. But I have the one over here
So.
to the 5th, which ding, ding, ding. Right here.
Are we gonna have these on the test?
Yes,
Like
you
the-
are.
No, the theorems things or the identity things.
That's what I'm
The identity things. What, this? You don't know this?
No,
No.
all of
No,
them,
no,
just
no, no, no.
everything.
The
Like what?
5.1.
I don't know.
The
I already-
cosine squared plus sine
What?
squared equals 1.
All the ones that we've done so far, what is the identity? Really, truly, the only identity that we use is what?
Sine squared plus cosine squared.
Is
No,
equal to
but
what?
like-
So is that the only one we're gonna use?
That is the
haven't
one that is
memorized.
most important. I told you on the start, 80 to 90% of the time, that's the one you're going to use.
But what if that other 10%'s on the test?
If we're gonna use something else, we can.
But the other ones you can manipulate out of that one.
Takes
Because
effort.
manipulating is not a nice thing.
We did that, right? I told you how to glean that out.
I got somewhere in 18.
Okay, so we are done for the day.
Oh, Mr. Ron, can you do number 18?
Hang on a second.
No, 18.